Hello everyone, today in this video we are going to solve some problem on projectile motion. So after this video you should be able to apply the formulae of projectile motion to solve real life examples. So this is the path of a projectile and we can resolve the velocity of projectile into two components. One is u cos theta, that is horizontal component, and another is u sin theta, that is vertical component. So using this diagram we have found out the equation of trajectory to be like this, and we can find the time of flight by knowing the angle and the initial velocity. So the formula of time of flight will be given by this, and maximum height, this height will be given by this expression. Again, by knowing initial velocity and the angle of the projectile, we can find the maximum height and we can find the horizontal range. Horizontal range means the horizontal distance covered by the projectile. So we'll use this formula to solve the real life problems. So this is the first question: derive the condition for maximum horizontal range for a constant velocity. This question is asking what should we do to throw the projectile to cover maximum distance, but we cannot change the velocity. Velocity is constant. So horizontal range is given by this formula. So in order to make this h maximum, this side should be maximum. So RHS should be maximum, and in RHS you can see u square is constant, g is constant, so we can change only the angle. So for this side to be maximum, this sine 2 theta has to be maximum, and the maximum value of sine is 1, that is 90 degree. So sine 2 theta is 1, so 2 theta is sine inverse 1, and sine 90 is 1, so I can write 2 theta is 90 degree, sine inverse 1 is 90 degree. So if you solve this, you'll get theta to be 45 degree. If you throw the projectile at 45 degree, then it covers the maximum distance. So this is the next question. A cricket ball is thrown at the speed of 19.6 meter per second in the direction 30 degree above the horizontal. So we have to find maximum height, time taken or time of flight, or the range. So these are the things which are given. So time of flight is given by this expression. So I'll put the values. So sine 30 is half, I can write it as 0.5. so if you solve this, you'll get the answer to be this. Next we'll find the maximum height. So formula is given by this expression. So I'll put, so for sine square theta I can write sine theta whole square. So now I'll put the values and I'll get 4.9 meter. So maximum height is 4.9 meter. So similarly the range, so this is the formula, and this is 2 theta, so I'll multiply 2 and 30 degree, so you will get sine 60, and if you put the values you will get 33.9 meter. So I've got time of flight, maximum height and range just by knowing the initial velocity and the angle of the projectile. So in the similar way you can try this question. So just I have changed the speed, so these are the answers you can find. Now next question, a body is projected with the velocity of 30 meter per second at the angle of 30 degree with the vertical. Now there is small difference. In previous question it was with the horizontal, and this time it's the vertical, so theta is not given. So out here this angle is given, we need this angle, so we can easily find this angle. This is 90 minus 30, 60 degree, so theta is 60 degree. Now in the similar way you can find maximum height, time of flight and horizontal range. So you can try this question as well. So in this question again the angle is given with the vertical, initial speed is given, and one more thing is asks the time to reach the highest point. So time to reach the highest point is the half of time of flight. So after finding the time of flight we can divide this by 2 to get the time to reach the highest point. So in the similar fashion you can solve this question, only first you have to find the theta. So always remember, if the angle is with horizontal, theta is given. If the angle is given with the vertical, we have to find the theta by subtracting it with 90 degree. So this is the next question, find the angle of projection for which horizontal range and maximum height are equal. So out in this question, h is equal to r is given, theta is question mark. So h is equal to r is given. If you use the formula for h and r, you'll get this, and you can convert this sine 2 theta into 2 sine theta cos theta. Now you can cancel the things and you'll get tan theta to be 4, or theta is equal to tan inverse 4. So you can try from this step. So this is the next question. Prove that the maximum horizontal range is 4 times the maximum height obtained by the projectile, and the projectile is fired to attain the maximum range. So out here theta is given, because for maximum range theta is 45 degree, which we have already found. We have to find r is equal to 4h, and we know formula for h is given by this, r is given by this. So if you divide this two and put the value for theta, then you'll get r is equal to 4h. So just write these two equations and divide these two equations and you'll get the answer. And one more question. A projectile has a range of 50 meter and it reaches the maximum height of 10 meter. Calculate the angle. Now things which are given are range is given, height is given, you have to find theta. So we know formula for h is this, formula for r is this. Now you can put the value for h and r and divide these two equations, then you will get the answer. So the angle will come as theta is equal to tan inverse 0.8. So please try this question, put the values and divide two equations. Now these are some more questions which you can try by yourself. So in this question, a bullet is fired with the velocity of 140 meter per second and strikes the ground at the same level. This means range is given, range is 1 kilometer. In this question, a cricketer can throw a ball to maximum horizontal distance of 160 meters. So in first case, horizontal range is given, that means theta is 45. For maximum horizontal range, theta is 45. So you can find the initial velocity using these two things. Now for maximum height, you have to use theta is equal to 90 degrees. So for maximum height, theta has to be 90 degrees. So using this, you can find h. So this is the last question. Prove that time of flight t and the horizontal range r of the projectile are connected by this equation. So write the formula for time of flight and write the formula for range. As we need t square, so square this equation for time of flight and divide the equation t square by r, then you'll find this expression. So this is the end of the video. Please don't forget to like the video and subscribe the channel. So out here I have given my number. If you want help in any topic, you can WhatsApp me in this number. I will try to help you. Thank you.